Hello, everybody. I am Marco Varlese, architect on developers, technologies, and artificial intelligence here at SUSE. And I'm here today to briefly introduce you to the artificial intelligence machine learning initiative that we are pursuing within SUSE. I would like to start with painting a picture in your mind about the journey around AI. The journey for a full stack solution around AI is quite long and impervious one. If you imagine climbing a high and steep mountain made of various peaks along the way, right? And we want to reach the final peak on these huge mountains. The two climbers that are on this journey, they represent our main two actors. One being the developer and the other one being the operator. They have very different roles along this journey and requirements to fulfill. And these requirements, in many cases, are actually orthogonal to each other. Taking that into account, I wonder, how does the plan look like to bring us to the very top of the mountains? And where are we today? One important caveat around the journey and the two actors is they both have to reach the final peak together. It's important that they will enjoy the beautiful view from that peak together in good company. So first, we had to look at our first delivery mechanism, which in SUSE and which on our distribution is represented by RPMs. So we tackled the first peak by looking at the mostly used artificial intelligence frameworks today, libraries, tools, all those software components which are being leveraged by data scientists to accomplish their goals. On the second leg of our journey, we have also looked into how we could deliver the same technologies in different ways with different delivery mechanisms. And this is where we started looking into containers, virtual machines, appliances, and last but not least, WSL, the Windows subsystem for Linux. The data scientists virtual machines, as they are called among data scientists, we basically looked into a variety of hypervisors. And so today you can actually find them available for KVM, Xen, VMware, and last but not least, Microsoft Hyper-V. We are currently looking into a customization for WSL, which will be targeted to data scientists. Still early days, but it would be awesome when that will be ready to have a WSL image which can offer exactly the same tools, library, frameworks, the same user experience that we currently have today on our Linux distribution. This last deliverable would really bring us to the second peak, which is our second milestone. And this is what we call the playground, the place where data scientists can really enjoy doing what they do best. Because remember, something that we really care about is making data scientists' life easy. We don't want to have data scientists investing their time, their days and weeks to look into how to get their setup up and running, how to get a tool installed correctly, managed and updatable over time. We want to help you there. We want to take those steps for you so that you can do your job at your best. So now that we are on the second peak, we're still not done. There's still like the final last stint to be taken care of. And now the path starts going a little bit downhill, but yet it's full of obstacles. Right now, we need to deliver more frameworks, tools, which will be helping us during the third leg of our journey, while climbing our last peak. These frameworks, though, are not targeted to developers only, but to operators too. Finally, in order for us to reach our last peak, where we have the overall artificial intelligence solution, we'll need to look at very important aspects from a production point of view, as well as from a pure 360-degree enablement. That is the reason why at the very last, we have things like resource management, multi-GPU vendor support, pipelines management, and monitoring and reporting. The truth was that the last peak, as I'm picturing it through you right now, is not really the last one. There's still a lot to be done, but the journey past the third peak is way too blurred at the moment to really give you an idea of what will happen next. So after all this walking and climbing, how does the architecture contemplating both the developers and the operators look like today? Well, if you look at the diagram that I'm showing you here, on the left-hand side, enclosed by blue dotted frame rectangle, we can see the AI playground, what I mentioned to you being the playground. At the very top, in the light blue area, we can see the frameworks, the tools, the libraries, all those tools that are very well known by data scientists and what they basically use on a daily basis. As I said earlier, the first milestone is really represented by RPMs because they represent the foundational building blocks of our other delivery vehicles, being either containers, appliances, and custom WSL image. All of them today, they can run on Tumbleweed, which is our rolling release, on Leap 15.2, and they will also be available for our enterprise editions, LES 15.2, through the package app repositories. On the right-hand side of this picture, we can find a platform targeted to production, or basically what operators are very interested in. From the very top, we can find TensorFlow Extended, or TFX, which is becoming the de facto standard when developers are ready to go beyond training a single model or ready to put their amazing model and work to production. TFX allows the building of a complete machine learning pipeline, and it is becoming more and more popular due to its strong relation with TensorFlow. A TFX pipeline is nothing more than a machine learning pipeline in more general terms. It's a sequence of components that implement a machine learning pipeline which specifically is designed for scalable, high-performance machine learning tasks. TFX has only one hard requirement, and that's represented by Apache Beam. In very short, Apache Beam is an open source unified model for defining both batch and streaming data parallel processing pipelines. TFX uses Apache Beam to implement data parallel pipelines. The pipeline is then executed by one of the Beam-supported distributed processing backends, and here we can find, among others, our next component, which is Apache Spark. Apache Spark, again, in very short summary, is a fast and general-purpose cluster computing system. It provides high-level API in various different programming languages, such as Java, Scala, Python, and R, which happen to also be the top-rated programming languages for machine learning data scientists, and an optimized engine that supports general execution graph. It also supports a rich set of higher-level tools, including Spark SQL for SQL and structured data processing. It supports MLlib for machine learning and GraphX for graph processing. Obviously, it also supports its own very much Spark streaming. The Spark cluster mode overview explains the key concepts in running on a cluster. So please refer to that if you're interested more into the details of how Spark works and what Spark can do. The interesting aspect of Spark is that it can run in multiple ways. The first one, I would say, the one that helps to get things started and bootstrapped and to be played along is standalone deployment model. Is the simplest way to deploy Spark on a private cluster. Beside that, we then have Apache Mesos, Hadoop Yarn, Kubernetes. Now we have the optional components of the stack, which are not just helping to scale out the workloads, but also to enrich and manage the machine learning pipeline. The first two are the Apache Airflow, which is a platform to programmatically author, schedule, and monitor workflows. TFX, in this case, uses Airflow to author workflows as directed acyclic graphs. The very rich user interface makes it easy to visualize pipelines running in production, monitor progress, and troubleshoot issues when required. When workflows are defined as code, they become more maintainable, versionable, testable, and collaborative. That's what Airflow is really aiming to. The other optional component is represented by Kubeflow. Kubeflow is dedicated to making deployments of machine learning workflows on Kubernetes simple, portable, and scalable. Kubeflow's goal is to provide a straightforward way to deploy the best of the breed open source systems for machine learning to diverse infrastructures. Kubeflow pipelines enable a composition of and execution of reproducible workflows on Kubeflow, integrated with experimentation and notebook-based experiences. So people that are familiar with the jupyterlab/hub idea approach, they will find Kubeflow pretty much in line with what their past experience is. Something I would like to stress is, while these components are very much optional in our AI architecture, they are very much more than just nice to have components. They will basically offer the scalability and portability across infrastructure that no other components can actually offer today. Last but not least, machine learning, deep learning in general, uses huge data sets to enrich and validate models. So it is foreseeable on the need for storage solution, which in our case here in SUSE, it's represented by SAS, our storage enterprise solution. Finally, as per earlier slide, we need to ensure to support a multitude of hardware vendors who are providing various different GPU-based platforms to accelerate computation of intensive mathematical tasks. In this space is where we find Intel, AMD, NVIDIA, and ARM. So now that we have a picture in mind of how the stack looks like, how are we actually delivering it? It's quite complex stack, many different components which can update, on their own, on a different cadence, and we need to make sure that they can coexist in an harmonious way. Well, it is all done via the Open Build service, which is offering not only capabilities to build and test RPMs, but also to leverage those foundational building blocks to create derived artifacts. In this case, as I mentioned before, they are represented by the DSVM, so the data scientists, virtual machines, the containers, and hopefully very soon a custom WSL image for data scientists. All of those then eventually publish those artifacts on different repositories being either the openSUSE registry or eventually the Windows Store for WSL or our own repositories for RPMs, which for the openSUSE distribution, for example, is represented by download.opensuse.org. What I would like to finish with is, please try our solution, use it, play with it, let us know what you think. If it meets your expectation, if you find difficulties in using one tool versus another, if the day one experience is pleasant enough to make your journey and your development a much easier one and much more pleasant one. So please reach out to me, reach out to us, and we will be more than happy to listen to you and help you to get to the next step for our products and to help you in your journey. With that, thank you very much. Have a lovely day and talk to you soon. Bye.